like I said at the beginning, we have two motions. The first motion is the Earth rotating on its axis, and this motion is approximately 24 hours, and that causes the stars to appear to move around in a 24-hour cycle. So if you look at a given star, and let's say it's 10 p.m., that star will move around in a 24-hour cycle, and 24 hours later, at 10 p.m. the next day, it will be approximately in the same location. Not exactly, but approximately so. So this 24-hour cycle is kind of the dominant motion that I want to talk about today. And then motion number 2 is due to the revolution of the Earth around the Sun. Motion number 2 is somewhat secondary for reasons that we'll get into later. So motion number 1, the rotation of the Earth, is the one that we want to talk about first. And again, let's try to keep these relatively separate. So this 24-hour motion causes every star and galaxy and the planets, more or less, although they have their own motion not accounted for, all the comets, all of that stuff is going to be going around in approximately 24 hours. If you look towards the north, this 24-hour cycle makes everything appear to go around the North Celestial Pole. We happen to have, in the northern hemisphere, a wonderful star called the Pole Star, or Polaris, which is approximately at the location of what's called the North Celestial Pole. And I will point out this North Celestial Pole on a different diagram coming up. For now, let's just use that as a reference point. This is the direction that the Earth's axis points. So if you can imagine the Earth's axis passing out of here, it's going to point directly at the North Celestial Pole. And then as the Earth rotates, Earth rotates this way, the stars are going to appear to go around the North Celestial Pole. This is the view that we have when we are looking north. We have a special word for stars that neither rise nor set in this 24-hour motion, and that is the word circumpolar. The circumpolar stars are always up. And some of the most prominent ones are in the Big Dipper, or Ursa Major. This is why Ursa Major is a great constellation to know and impress your friends with, because it's basically always up. So you can always find it if you can locate the northerly direction. It's relatively bright, and only the last star in the Big Dipper sets from our vantage point here in West Virginia. So we can always find Ursa Major because it is a circumpolar constellation for the most part. Ursa Minor, the Little Dipper, is fainter, but it's even better in a sense because it is further towards the North Celestial Pole, so it is always circumpolar from every vantage point, I believe, in the continental US. So this is our view from the north. The stars are, for the most part, going to go around the North Celestial Pole without rising or setting. Everything rises toward the east. You guys have probably learned that when you were kids. Things rise in the east instead in the west. So the stars are going to rise when you are looking towards the east. Here are two constellations that are relatively famous, Gemini and Ryan. Orion, interestingly, rises approximately due east. So remember that for later, because that's actually kind of important. Not for Orion, but for understanding the motions of the night sky. If you look toward the south, objects will pass through the south and then set again in the west. And at some point in my teaching history, I lost my looking west slide, so you'll have to imagine what it looks like. But it is the opposite of looking east. Everything just sets. So you can imagine Imagine everything rising towards the east, and then here in the south, it's going to be passing up, and then in the west, it's going to be setting.
With the slide, you could
You could
horizontally flip it.
yes, you can. Let's see, I could probably finagle a way to flip this, but all of these lines would have to be right. They'd have to be inverted so that it's actually setting. We have a special word for this process of passing through directly south or directly north, and that is transiting. And so I will bring up that word at times, especially in the planetarium. When an object is transiting, it is at its highest point in its 24-hour motion. That becomes important because it's best practice. You'll get the best data if you point your telescope not towards the horizon, but off the horizon. And an object is furthest off the horizon when it is transiting. There's a slight complication for objects that are circumpolar in that they actually have two transit points, one and then two. Ignore that for now. That's not super important because at both transit points, for many of these stars, it's well off the horizon.